1,200 years ago, a group of monks tried to defeat death itself. They failed, but what they accidentally created didn't just fail to save lives. It went on to end millions of them. It toppled castles that had stood for centuries. It rewrote the borders of empires. It quietly decided the outcome of nearly every major war for the next 1,000 years. And the strangest part of this entire story? For years, the people who made it had no idea what they'd actually built. This is the real story of how a desperate search for eternal life gave birth to one of the deadliest inventions in human history, gunpowder. To understand how gunpowder was born, you have to go back to a world where death wasn't just feared. It was treated as a problem to be solved. In 9th century China, during the height of the Tang Dynasty, China was one of the most advanced civilizations on Earth. It had wealth, poetry, trade networks stretching along the Silk Road, and a sophisticated imperial court. But for all its advancement, one obsession sat at the very top of Chinese society: immortality. Emperors did not want to simply rule for a lifetime. They wanted to rule forever. And surrounding them was an entire class of scholars, priests, and mystics known as Taoist alchemists, whose life's work was dedicated to a single, all-consuming goal: discovering the elixir of immortality. A potion, powder, or pill that could stop the body from aging, cure any disease, and let a person live on indefinitely. This wasn't some fringe belief practiced in secret. Taoist alchemy was state-sanctioned, court-funded, and taken with total seriousness at the highest levels of government. Emperors employed personal alchemists, the way modern leaders employ personal physicians. Entire laboratories were built inside palace walls, funded directly by the imperial treasury, dedicated purely to the pursuit of eternal life. And here's the part that makes this story almost unbelievable. Historical records suggest that at least several Tang emperors may have actually died from the very elixirs meant to make them immortal. Many of these so-called immortality pills contained mercury and arsenic, substances that alchemists believed carried powerful life-giving properties, precisely because they didn't rot, rust, or decay the way organic matter did. To an alchemist's mind, a substance that resisted decay might be able to pass that same resistance onto the human body. It was a logical theory built on a completely wrong premise, and it was slowly poisoning the very people it was meant to save. So alchemists kept experimenting endlessly, mixing minerals, metals, plant extracts, and natural compounds, heating them over clay furnaces, cooling them, grinding them into fine powders, recording results in secretive texts, passed down through generations of practitioners, each one hoping to be the one who finally cracked the formula for eternal life. Three ingredients kept reappearing across countless experiments: sulfur, charcoal, and a curious mineral known as saltpeter, what modern chemistry calls potassium nitrate. On their own, none of these seemed remarkable. Sulfur had long been used in traditional Chinese medicine, believed to have healing and purifying properties. Charcoal was common, unremarkable, found in every household hearth. Saltpeter was the strangest of the three, a naturally occurring white, crusty mineral that formed on the walls of caves, cellars, and old stone buildings, almost like frost that never melted. Alchemists were drawn to it because it seemed to appear out of nowhere, and because early experimentation suggested it had preserving qualities. It could be used to cure meat, for instance, which fed directly into the alchemical obsession with anything that resisted decay. But here's what's critical to understand. Nobody in that room had any real concept of chemistry the way we understand it today. There was no periodic table, no theory of oxidation or combustion, no understanding of chemical reactions at all. Alchemy operated on a mixture of observation, philosophy, spiritual belief, and sheer trial and error. Alchemists were, in the most literal sense, running blind experiments on substances whose true properties they didn't understand, chasing the door to eternal life with absolutely no idea that some of what they were mixing together was capable of burning violently or exploding outright. And it's exactly at that intersection desperate ambition, meeting total scientific ignorance, that the story of gunpowder truly begins. Somewhere around the mid to late 9th century, a Taoist alchemical text later compiled under the title Zhenyuan Miaodao Yaolu, roughly translated as classified essentials of the mysterious Tao of the true origin, recorded something that would end up being one of the most consequential warnings in human history. The text described a formula, sulfur, saltpeter, and a carbon-rich plant substance, likely a form of honey or charcoal-like organic matter, mixed together and heated in the course of an alchemical experiment. According to the account, the mixture didn't produce a life-extending vapor or a mystical transformation. It produced flames, flames that leapt up violently, singed the hands and faces of the alchemists working with it, and in at least one recorded instance, burned down the very building where the experiment was taking place. This wasn't written as a triumphant discovery. It was written as a warning to other practitioners. Do not attempt this combination. We tried it, and it went badly. Pause on that moment for a second, because it deserves to be pictured clearly. A dim, smoky workshop, clay furnaces glowing with low heat. An alchemist, likely middle-aged, highly educated, deeply devout, carefully measuring out powders by hand in pursuit of the single greatest goal of his life, eternal existence. And then, without warning, a sudden violent burst of fire. Scorched eyebrows, burned hands, smoke filling the room, maybe the entire structure catching flame around him. There was no cinematic eureka moment here. There was panic. There was injury. There was very likely fear that they had angered whatever spiritual forces they believed governed the universe. Nobody in that room walked away thinking, "We've just discovered the basic chemistry behind explosives." As far as they knew, they had failed completely at their actual goal and gotten badly hurt in the process. The irony of it is almost unbearable. In trying to create the substance that gives life, they had instead created one of history's most efficient tools for taking it away. The Chinese eventually gave this volatile new substance a name that reveals exactly how it was understood. At the time, huiyao, meaning fire drug or fire medicine, not weapon, not explosive, a drug, because it was born inside a medicine cabinet, conceived by people trying to heal and preserve life, not people trying to destroy it. For a significant stretch of time after its discovery, gunpowder existed in a strange, undefined space, something alchemists and craftsmen knew could burn violently and unpredictably, but which nobody had yet consciously connected to warfare or weaponry. Over the following decades, the formula was slowly, cautiously refined, not by scientists in the modern sense, but by craftsmen and alchemists adjusting ratios through repeated, dangerous trial and error. They discovered that different proportions of sulfur, charcoal, and saltpeter produced dramatically different results. Some mixtures burned slowly and steadily. Others flared up violently in an instant. Some produced thick, choking smoke. Others produced sharp, sudden bursts of light and noise. By the 10th century, this fire drug had begun moving out of secretive alchemical texts and into public, everyday life, most famously in the form of early fireworks. These were used during religious festivals and celebrations, largely because the loud bangs and bursts of fire were believed to scare away evil spirits and malevolent forces. For a good while, that was essentially all gunpowder was to the average person in China: noise, color, and spectacle tied to superstition and celebration. Nobody, at this stage, had yet made the leap to imagining this same chemical reaction as a weapon capable of killing another human being. That realization was still coming, and once it arrived, it would never be undone. By the 10th and 11th centuries, China was not at peace. Rival kingdoms fought one another for territory and legitimacy. Nomadic groups pressed in from the north, and looming on the horizon was the eventual rise of the Mongol Empire, one of the most formidable military forces the world had ever seen. In a world already saturated with near-constant warfare, it was only a matter of time before someone looked at fire drug, this strange substance known mostly for scaring off spirits at festivals, and saw something far more practical, a weapon. The transformation didn't happen overnight. It happened gradually, through a series of increasingly deadly experiments carried out by military engineers, rather than religious alchemists. One of the earliest true weaponizations was the fire lance, a bamboo tube packed with gunpowder and attached directly to the end of a spear. When ignited, it would spit a burst of flame, smoke, and sometimes shrapnel or debris toward an approaching enemy for a few terrifying seconds before burning itself out. By modern standards, it was wildly impractical, short-ranged, unreliable, and used up in a single burst. But against soldiers who had never encountered anything like it, a spear suddenly erupting into fire and smoke was often enough to shatter enemy formations and morale in an instant, even before any real physical damage was done. From there, Chinese military engineers began experimenting rapidly and deliberately. Gunpowder was packed into thick clay and metal shells and hurled using catapults and trebuchets, producing some of the earliest true exploding bombs in recorded history. Fire arrows were tipped with small gunpowder charges, designed to ignite enemy structures, ships, or supply stores from a distance. And rockets, one of gunpowder's most iconic and enduring inventions, emerged during this same period. Initially developed less for their destructive power and more for their psychological effect. A rocket's shrieking flight through the night sky, followed by a burst of light and fire, was often as effective at terrifying enemy troops and horses as it was at causing actual physical harm. By the 12th and 13th centuries, during the Tang Dynasty, gunpowder weaponry had become a serious, institutionalized part of Chinese military strategy. The Song government even established dedicated workshops for gunpowder weapon production, employing thousands of workers to manufacture bombs, fire arrows, and increasingly sophisticated fire lances. It was during this period that the fire lance took its most important evolutionary step. The fragile bamboo tube was gradually replaced with metal, and solid projectiles were added into the mix alongside the gunpowder charge. What resulted was something recognizably close to the earliest true firearm: a metal tube, a gunpowder charge, and a projectile fired down a barrel. Historians widely regard these Song Dynasty devices as the direct technological ancestors of the modern gun. What's genuinely remarkable, looking back, is how quickly the entire purpose of gunpowder flipped in the span of roughly 3 centuries. The same chemical reaction that had once been feared as a dangerous accident inside an immortality lion, once a technology that powerful, exists in one corner of the world. History shows us again and again that it almost never stays contained for long. Embroidery had become a deliberately engineered instrument of war, refined, tested, and mass-produced by military strategists who fully understood, unlike the original 9th century alchemists, exactly what this substance could do and precisely how to make it do more of it. And once a technology that powerful exists in one corner of the world, history shows us again and again that it almost never stays contained for long. Gunpowder did not remain a Chinese secret for long. Through expanding trade networks, direct military contact, and above all, the explosive 13th century conquests of the Mongol Empire, knowledge of gunpowder, and eventually the weapons built from it, began spreading rapidly westward across the known world. The Mongols, who at their peak controlled the largest contiguous land empire in human history, stretching from the Pacific coast of China to the edges of Eastern Europe, are widely credited by historians as one of the critical bridges in this global spread. As Mongol armies expanded across Asia and pushed into the Middle East and Eastern Europe, they carried gunpowder weapons and gunpowder knowledge along with them, sometimes as tools of conquest, sometimes as captured knowledge absorbed from the very civilizations they defeated. From Mongol-controlled territory, gunpowder technology reached the Islamic world by at least the late 13th century. There, engineers and military scholars, including figures like the Syrian scholar Hassan al-Ramah, who wrote extensively on gunpowder formulas and incendiary weapons, began developing, refining, and in some cases significantly improving upon the original Chinese designs. Arabic and Persian military texts from this period contain detailed gunpowder recipes and descriptions of early cannon-like weapons, showing just how quickly this fire drug had transformed into a serious, formalized science of warfare across an entirely different civilization, thousands of miles from where it began. By the early to mid-14th century, gunpowder technology had reached Europe, likely transmitted through a combination of trade along the Silk Road, contact with the Islamic world, and reports carried back by travelers and diplomats, European blacksmiths and military engineers, working with a chemical formula whose basic building blocks had been discovered by accident half a world away by Chinese alchemists desperately chasing eternal life, began constructing cannons, heavy, crude, dangerously unreliable at first, prone to misfiring and even exploding on their own crews. But they were capable of doing something no siege weapon in the history of warfare had ever managed to do, reducing centuries-old stone castle walls to rubble in a matter of hours, rather than the months or even years a traditional siege might require. This single technological shift didn't just change how individual battles were fought, it fundamentally restructured the entire balance of power across the medieval world. Castles that had protected noble families and controlled entire regions for hundreds of years suddenly became vulnerable almost overnight. Kingdoms and city-states that could afford to invest in cannons and gunpowder weaponry gained a decisive, often overwhelming advantage over those that couldn't keep pace. Warfare itself, which had been dominated for centuries by armored knights, mounted cavalry, and heavily fortified walls, began its slow but unstoppable transformation into the gunpowder-driven warfare that would go on to define the next several hundred years of human conflict, a lineage running directly from those early cannons, through muskets, rifles, artillery, and ultimately into the firearms of the modern world. And it all traces back, in an almost impossible-to-believe way, to that single moment centuries earlier, a dim, smoky workshop somewhere in Tang Dynasty China, a handful of frightened, singed alchemists, and a mixture of sulfur, saltpeter, and charcoal combined in a desperate, sincere search for a way to cheat death. They never found immortality, not even close, but in trying and in failing, they created something that would go on to shape the rise and fall of empires, decide the outcomes of countless wars, and quietly sit behind nearly every major shift in global power for the next 1,000 years of human history, all because of a mistake that nobody standing in that room even fully understood they had made. That's the strange, uncomfortable truth about some of history's most consequential discoveries. They weren't always born from genius, careful planning, or deliberate ambition. Sometimes, they were born from failure, from human beings reaching desperately for one thing and accidentally grabbing hold of something else entirely, something so much bigger and so much more dangerous than anything they had originally set out to find.